or ADC 0809 with 8051 microcontroller. Now, in my last lecture, I have shown one configuration which I made to interface this particular ADC with 8051, where I considered my A channel is connected to P1.0, B is connected to P1.1, C is connected to 1.2. Then, and you can remember ABC are the channel lines of ADC. Then D0 to D7 of ADC, that is the data line of ADC, is connected to port 2 of 8051. Then you have address latch enable is connected to 1.3, start conversion is connected to 1.4, EOC is connected to 1.5, and OE or output enable is connected to 1.6. I used P3 to show the corresponding digital value through LED, because whatever analog voltage I have applied in the IN0 line by putting a value of ABC, because if you can remember in the last lecture I mentioned if ABC values are 0, 0, 0, then you have to give input in the first line, and if it is 0, 0, 1, you have to give in analog input to the second line, and so on. So what analog input I have given to this input line, its corresponding digital value I am going to get through D0 to D7, and that I am going to collect through port P2, and that I am going to display or show through P3 port. This was my configuration. Now in this lecture I shall discuss how to write the assembly language code to get such kind of thing, or to do such kind of interfacing, and what are the steps you have to follow. Now, in this coding technique, you have to follow these steps. Okay, to write the assembly language code, you have to follow these steps. Now, what are the steps? First of all, you need to determine the value of the channel ABC. Okay, so why? Because by putting an appropriate value in ABC, one of the 8 input lines, if you can remember, IN0 to IN7, one of them will be getting selected. Okay, so that is the step number 1. So you have to give an appropriate value of ABC. For example, 000. If I give, then IN0 is getting selected, means I have to give the analog input in IN0 number line. Okay, then step number 2. Activate the address latch enable. How to activate the address latch enable? In my last lecture, I already mentioned you have to give a low to high transition to this address latch enable line. That is, first you give a value of 0, then you make it 1. Okay. If you apply such kind of signal to ALE line, that address latch enable line will be activated. Okay. Then step number 3, start conversion. Start conversion is what? What analog voltage you have given, its corresponding digital value I want to get. So for that, in order to get that, I have to start conversion. And to do that, I have to activate the start conversion line. How to activate the start conversion line? Similar procedure what you followed for ALE. You have to make a transition from 0 to 1. Then the next step is check the status of end of conversion line. So what is end of conversion line? How to check the status? You know, I in the last lecture I mentioned if the conversion is going on, the by default value of EOC will be 1. Now how you can understand the conversion is over? When you will see the EOC line is getting a value of 0, or it is showing a value of 0, you need to understand that conversion is completed. Okay, so if conversion is completed, what is your next job? You have to activate output enable line. OE stands for output enable. How to activate output enable? You have to make a value of 1. Okay, so you have to make a value of 1 in the output enable. Then you can collect the data, whatever digital value you got from the analog to digital converter, the data you can bring it to 8051. Okay, so what you have to do? You have to make OE or output enable equal to 1. Then you can collect the value to your 8051 controller through your D0 to D7. And you know, these are the data lines of ADC that I discussed in the last lecture. Okay, now the last step is After getting this thing, immediately you need to disable the OE line. How to disable it? You make OE equal to 0. So these are the seven steps you need to follow to write the assembly language code. So what are the steps? Again, I am discussing. First of all, you determine the value of ABC. Then you have to activate those channel. So for that, you have to activate the address latch enable line. How to do that? 0 to 1 transition you do. So now you have latch that address. The next job is you start the conversion now. Start the conversion means what analog voltage you have given. Now you try to get its corresponding digital voltage, and to do that you have to start the conversion. So you activate the start conversion line. How to activate it? You make a transition from 0 to 1. Then next thing what you have to do? You have to check whether the conversion is over or not. How to check it? If conversion is going on, EOC value will be 1. If the conversion is over, EOC automatically it will get a value of 0. After that, what you have to do? Activate the OE line. OE stands for output enable. When the conversion is over, immediately you need to activate the OE line. How to activate it? Make OE equal to 1. And after making OE equal to 1, you collect the convert a digital value to your 8051 controller. And finally, you disable the OE line by making it 0. So these are the steps to be followed. Now I shall discuss the assembly language code, because here I discuss the steps. Now how to write the code, that I am going to show. So here these things I already discussed in my last lecture in the configuration. If you can remember, I'll show this picture once again. This configuration I have used, that I discussed in my last lecture, and I have uh, make a note. I have made a note of all these things. My A is connected to the A channel of ADC is connected to P1.0 of 8051. So the left side contains the 8051 part, and the right side of the equation contains the different pins of ADC. Okay. So A is connected to 1.0, B is connected to 1.1, C is connected to 1.2. Then ALE of ADC is connected to 1.3 of 8051, S is connected to 1.4, EOC is connected to 1.5, output and is connected to 1.6. The data line of ADC, that is your D0 to D7 of ADC, is connected to port 2 P2, and whatever P2, whatever the digital voltage or whatever the digital value I am going to get through P2, that I am going to display in P3 through LEDs. Okay. To show the display value, I have used this port P3, where I am going to connect 8 different LEDs. Okay. Now see the assembly language code. Now org 000H, because if I write any assembly language code in Keil, I have to write org 000H, and that is the starting address. Not it is mandatory, you can use any starting address. So generally we use org 000H, that's why I use that thing. It's your wish. Then in according to my configuration, P2 is is a input, not an output. Okay. Why P2 is an input? What in any interfacing problem, we consider input or output with respect to my controller point of view or processor point of view. Okay. So if you can remember, if you see this picture, the corresponding digital value what I got through D0 to D7, that I am bringing to P2. So it means the data is coming from D0 to D7 to P2. The direction is this one. So from controller point of view, this is the controller. For controller point of view, this is an input actually. So that's why P2 will be considered as an input. Now, when in any controller problem, something or 80, or specifically if I tell in 80 controller, if something is considered as an input, it is initialized as FF. Okay. And P3, I am going to show the corresponding digital value through the LEDs. Okay. And P3 was used as an output. Just few minutes before I told, in P3 I'm going to connect some LEDs. So this is my output. So if something is used as an output, I have to initialize the value as 0, 0. That I think everyone knows. If it is used as an input, it should be FF. If something is used as an output, if some port is used as an output, that should be 0, 0. Okay. Now other than that, some initial values also I am considering here. First of all, what I am considering? I am considering that my ABC values are 0, 0, 0. Okay, so how to make it 0, 0, 0 in assembly language code? CLRP 1.0, CLRP 1.1, CLRP 1.2. Hopefully you can remember that this is your A line, this is your B line, this is your C line, C channel. Okay, so I am making it 0, 0, 0. So 0, 0, 0, what does it mean? I have selected IN 0 to give my analog input. Okay. Now, after that, what you have to do? CLRP 1.3. Now, why I am doing all these things? Because these are used as either input or output. For example, what was 1.3? Address latch enable. Where address latch enable was connected? P 1.3. So, address latch enable, you have to give an appropriate value to address latch enable. Now, you see, from controller point of view, because I told whether it is an input or output in any interfacing configuration, you need to think with respect to controller point of view. Now you see, ALE should be means ALE should get an appropriate value. If you can remember, just few minutes before I told, it should get a transition from 0 to 1. How to give the transition? Through P1.3. So who will be generating the value? P1.3. Okay. So from controller point of view, this value should come from 1.3, P1.3, and that has to be transmitted to ALE. Means the direction is this one. Okay, so if you see, if the data direction is this one from controller point of view, this is an output only. Similarly, if I have to give an appropriate value in SC, through 1.4 I have to give. So this is also an output. This is the direction. Start conversion line also has to be considered as an output from controller point of view. Now, similarly, end of conversion. If you can remember, this will show you whether conversion is over or not. So definitely the value will be obtained from the ADC. So how the means data is getting transmitted from year to year, means through EOC generating some value that will be tracked through P1.5. So definitely from controller point of view, this is an output. Okay, why? The EOC value, if it is generating a value of 0, you need to understand conversion is over. If it is 1, you need to understand conversion is going on. So from controller point of view, controller is getting some value through EOC. Okay, so that is an output. And similarly, when the conversion is over, if you can remember, I told few minutes before, you have to enable the output value so that the value what you got through D0 to D7 in your ADC, that can bring to controller through P2. Okay, so definitely this is also an output, because you need to give means appropriate value in OE line, and that is nothing but you need to make it 1. Okay, you have to make it 1. How? Through P1.6, and that from processor point of sorry, controller point of view, this is an output. Okay, so if something is used as an output, it has to be 0. If something is used as an input, it has to be 1. This is the initialization procedure. Okay, so output means these are zeros. So you see what we have done. Now let's come back to the program again. CLRP 1.3, this is really, this is an output. That's why this is clear. Then if you can remember, P1.4 was start conversion. This is also was this one was also an output. Then P1.5, if you can remember, this was end of conversion, and this is an input from controller point of view. So that's why set B P1.5. This should be 1. How to make it 1? Set B. You know very well. Then 1.6 was, if you can remember, output enable. This was a output line. Okay, so we are making it as it is an output, initializing by 0, and later on we have to give the appropriate value here to activate it. Okay, now come to the main program part. So initialization is over, we have given the appropriate value. Now first of all, what to do? I have given the corresponding value in ABC. Now what I have to do? I have to start my conversion. So what is the process you need to follow? I told to activate the no, sorry. First of all, I need to activate my address latch enable line. If you can remember, just few minutes before I told, the step is what you have to do here. You have to activate the address latch enable line. So how to do it? You make a transition from low to high. So how we are doing here? First of all, we are setting the value of P1.3. So you will be having some confusion by looking at this set BP 1.3, because ideally as we are doing 0 to high transition, the idea is coming to your mind, it should be clear, the instruction should be clear, but you don't think it like that way. If you can remember, already we had taken some clear value, so it is having a value of 0. Now to activate it, I need to make a 0 to 1 transition. As it is already having a value of 0, to make it high, I have to give it set. Okay, so it is already getting a transition from 0 to 1. I think now this is clear to everyone. Now as it should have a 0 value for some unit of time. I'm using NOP to get certain amount of delay, so it will remain the value of 1. And next time, if again has to come back here in the main program, I have to make it ready. So what I am doing, again I am making it 0, so that next time when I need to come back here, it can get the set B line, so it can have a transition from 0 to 1 again. So what I am doing, whenever I am getting 1, immediately after certain time or after NOP, using NOP instruction, I am making it 0, so that next time if I come back here, automatically I can make a transition from 0 to 1. Okay, I think now this is clear to everyone. Now same thing I am doing for 1.4 start conversion. What is the procedure? Make a transition from 0 to 1. As start conversion already we have a value of 0. Now when it will come to this line, it has to be 1, so that you can get a transition from 0 to 1. That's why set B1. And same thing you have to do after certain time, you have to make it 0, so that next time when you will come back here, it should have a transition from 0 to 1. So after making it 1, after NOP instruction, means after some delay, again I am making it ready for the next time. What I am doing here, CLRP 1.4. So I have activated ALE, I have activated start conversion. What is your next job? You have to check whether EOC is becoming 0 or not. So what instruction you need to use? JB, jump bit P1.5. You know, 1.5 was connected to EOC. So it means if P1.5 remains 1, you have a you have to follow a self loop. So this will be waiting here or keep on iterating here. Now, when this 1.5 is 0, then you will come out from this loop. You need to execute the next line. And when it will be 0, definitely when the conversion is over. So conversion over means you have to do the next operation. What was the next operation? If you can remember, the next operation is activate the output enable line, so that the converted value can be collected to the P2 port of 8051. So what I'm doing here, set BP 1.6. This is the way I'm activating the output enable line. How to activate the output enable line? Output enable has to be made 1. So what I'm doing here, set B P 1.6. After that, what you need to do? The value what you got in P2, that you bring it to the accumulator. So move A comma P2. Okay, the value what you got in P2, that you collect in accumulator. Why? Because I need to show that value in P3. So port to port direct transmission is not possible, because port 3 I am using to display the value through LEDs. So that's why I am taking the value from P2 to accumulator first, and later on I'll again give the value of accumulator to the port 3 to display those corresponding hexadecimal value. Okay, so move A comma P2. Then what is the next thing you have to do? So in OE also you need to follow the same kind of thing. You have activated, you have made it 1. Then after taking the data, immediately you make it 0. So the next time if you come back, again you can make it 1. Okay. So what I am trying to say, first you make OE equal to 1, then collect the data to accumulator, then you make immediately O equal to 0. Okay, so it means clear P 1.6. Now the value what you got in accumulator, that you bring it to the P3 port, where some LEDs are 8 LEDs are connected, and you need to keep on repeating the same process, so that you can do the conversion for the next analog value. So again, short jump back means you are coming back here. Okay, and you need to keep on iterating to get all the corresponding analog values, corresponding digital or hexadecimal value. Okay, so hopefully this program is clear to everyone. Thank you very much.